Okay, so welcome to this new video series we're doing. This one is different from our unikernel application spotlight because we're going to be focusing on the various types of vulnerabilities that exist in software and how unikernels either A, help completely eliminate them, in the case of, say, system command injection, or we reduce the severity of them. And so this video, we're kind of looking at the latter. We don't actually eliminate this, and I'll talk about how and why, but we do, reduce the severity of it quite a lot, and I'll explain why I say that too. Um, so real quick, CWE, common weakness enumeration. It's basically a very long list of different ways that you can attack software. And this website from MITRE does a pretty good job of showing you, describing what the problem is, describing the common consequences and how to mitigate them. And then the relationships also are pretty important, and we'll probably get into the relationships later on throughout the series, and it gives you some examples. Okay, so what does this one talk about? This one talks about deserialization and serialization of objects. Pretty much every language has this capability. We're going to be looking at Python today because it's super easy to show. But PHP, Java, Go, like literally every language has this. And a lot of the language native stuff is particularly bad. And that's why there's like 20 other standards out there to do this sort of stuff. But essentially what happens is, like, from a vulnerability perspective, what happens is, if you accept input from, say, your user, your malicious user, and it's just like binary input, you don't really know what the hell they're giving you, right? They could, they could give you something that is good. They could also give you something that's really bad and wipes your drive or something like that. And so you want to be careful what you accept. And, in the case that we're going to show you, I mean, there's really no reason to ever accept any of this stuff from them. But let's look at Python. So we're going to be picking on Pickle from Python today. Obviously, you can see the big red banner here saying only unpickled data you trust. Consider signing the data, considering using other serialization things like JSON. Real quick, something like JSON is not so easy to serialize binary data from and to. You can do it, but there's differences. So maybe you might you encode it first before you throw it in JSON type of thing. But yeah, this is just Python's native way of serializing, deserializing data. And what makes this particularly harmful is if you have access to insert this stuff, you can spawn a shell, you can install a cryptominer, which is extremely popular to do in PyPy and other Python packages that you'll find out there. It's an attack that we see, like, not slowing down but speeding up in the past couple of years. And yeah, it just kind of sucks. So let's get into the example. Let me stop talking. All right, so this is basically our vulnerable application right here. Essentially, we try a good example and a bad example. Dumping and loading is basically your deserializing and your serializing from Python code to a binary format that you can, like, potentially save to disk or pass around or send over the net, do whatever. And then we load it up and it gets interpreted, and then Python goes ahead and executes whatever it wanted to execute. So the canonical good example is that, say, you just have this dictionary and you stuff a bunch of letters and numbers into it, So this is actually kind of useful sometimes, because maybe there's a lot more other crap that you have to do here, and it's kind of a pain to kind of read and sort and do all sorts of stuff when you could just like save the state of what you're doing. So say you're working with like a Jupyter notebook, so super common. Um, but therein lies the problem in that, you know, people also pass around Jupyter notebooks from user to user. And so you can see how this problem gets really crappy really fast. So let's look at the bad. The bad basically is as soon as you try to load this up, this reduce gets executed. In this case, we're calling out the OS system, but it could be literally anything. You could run a Python web server, and then now you have some sort of, you know, remote back shell that you could use. So again, when I mentioned that we don't completely get rid of this problem, this is a case where we don't completely get rid of this problem. Yes, you could potentially still serve a web shell in here. You could potentially delete some files here. You could potentially do some other things, but what you're not going to be able to do is install a crypto miner. What you're not going to be able to do is, you know, fork a shell. What you're not going to be able to do is run other stuff than the Python interpreter. So that's a really big key thing. So we're never going to be able to run this touch program, for instance. So that's why I say like this is a good example, because no, it doesn't get rid of everything, but it does heavily reduce the impact of what you can do to the extent that I think it takes a lot of the joy away from the attacker, right? So let's go ahead and run this locally. So this is without using unikernels. We do it, and obviously we have our owned file that gets put in here, right? Let's see if I can find the Python in our okay. So now we're gonna run it through a Nanos Unikernel, and let me just show you the config. Config is really basic. I considered keeping this in one file, but I figured we just break it apart, and so doing that, I had to have this config. Basically, our entry point is this main.py. Files, good, bad, main, yada yada, and we go ahead and run it, which is this guy. All right, so it ran it just fine, right? Now let's look at what got ran. And so if you haven't used ops before, we have ls and tree and some other tools to where you can look at it. And as you can see, there is no owned file with the rest of these like you would expect if you ran it locally. And so what happened here was it did prevent the execution of this being ran. Again, you could spawn like a Python web application, or you could call pure Python code to remove a file or something, but you're not going to be able to install, say, like a crypto miner and run it. You're not going to be able to spawn a shell. You're not going to be able to do many other things. And so in this case, we lower the risk of the CWE. So this is the first video in the series. We're going to go through lots of them because there's so many different things. And it's, you know, since Nanos is so different from Linux in terms of the architecture, things are just very different. But I hope you enjoyed this. And if you have questions, comments, let us know, and we can, you know, dive deeper into it. Till next time.